Hey everyone, I'm Daniela Passos, Dani, Developer Relations Lead at Hashnode, and I'm super excited to have you all here for our special workshop together with the MindsDB team. So we're getting up and getting everything ready and set for you to build your best AI agent at the MindsDB Hackathon. And throughout this event that is running from December 1st to January 15th, you'll get hands-on experience in building incredible AI agents using MindsDB. We have some incredible prizes lined up for you. So the top innovator will be awarded with a grand prize of $5,000, and we also have 5 runners-up with each worth of $1,000. Our agenda today is packed with insight, guidance, and knowledge prepared by the MindsDB team, and I'm super excited to introduce them to you. So they will walk us through how to effectively use MindsDB in your projects and build the best AI agent for this hackathon and this challenge. So without further ado, let's get started. And I'll bring up to the stage Martina. Martina, how are you doing today?
Thank you. I'm good. Hello, everyone. I work as a software engineer and a technical writer at MindsDB. And today, as Dani mentioned, we are going to introduce MindsDB to you and show you what is MindsDB, how it works, and how you can use it to build AI-powered applications easily and fast. So let me share my screen first. Okay, so we are going to start with a brief introduction to MindsDB. Then we'll move on to the demos on automation using the custom jobs feature and demos on agents and chatbots. So what is MindsDB? Well, MindsDB is an AI automation platform for that facilitates building AI-powered applications by bridging the gap between data and AI. So with MindsDB, you can easily connect any source of data, including relational, non-relational databases, vector databases, data warehouses, or even applications. Once you connect the data, MindsDB can access your data and use it for training the models and making predictions. So you can easily pass data into an AI model that is based on one of the AI frameworks available at MindsDB. You can easily create AI models based on AI frameworks, including OpenAI, Anthropic, Hugging Face, and more. Once you create a model, you can either train it with your data, or if it is an LLM, which is a pre-trained model, it does not require training then. The model produces predictions or forecasts, which you can then feed into another data source to create custom alert systems or chatbots. Furthermore, MindsDB enables you to automate the entire flow from inserting your data, passing it to AI model, and getting predictions and feeding predictions into end-user applications, which you will see in the following demos. What are the benefits of MindsDB? Well, one benefit is a unified AI deployment and management. Because MindsDB bridges the gap between data and AI, this eliminates the need to build and maintain complex data pipelines or separate systems for AI deployment. Furthermore, you can automate AI workflows. By AI workflows, we mean connecting your data, passing it to AI model, and getting predictions or forecasts back to some end-user application. MindsDB provides custom jobs feature that enables you to execute these AI workflows based on time-based or event-based triggers. So there is no need to build custom automation logic. MindsDB can help turn any developer into an AI engineer. MindsDB provides 5 development environments that includes SQL, MongoQL, REST APIs, JavaScript, and Python SDKs. This accelerates adoption of AI across teams and departments and can help turn any developer that knows one of these development environment into an AI engineer. Furthermore, MindsDB offers enhanced scalability and performance to meet the demands of your use case. Let's look at a simple example how you can enrich your data with the help of large language models and MindsDB. Any example usually starts with input data. So here, our input data is a table that stores Amazon reviews. So we've got a product name table and a review table. We want to enrich our data by adding a third column that stores sentiment of the reviews. And the values of this column are going to be generated by our model, or as we call it, a generative AI table. So now that we have our input data, let's move on to creating an AI model. MindsDB provides a custom create model syntax that creates an AI model and deploys it. So it is ready to use, and the model within MindsDB is abstracted as a virtual table, as we call it, a generative AI table. So these generative AI tables differ from standard tables in that they do not store any data, but they generate data upon being queried from the underlying model. Here, the underlying model is our OpenAI GPT-4 model. So let me walk you through this create model statement. So we create a model, give it a name as sentiment classifier. Then in the predict clause, we define a column. Here it is sentiment, where the model is going to store its predictions. Then the using clause consists of parameters which are specific per AI engine. Here we use engine as OpenAI, so one of the required parameters is prompt template. Prompt template here is a message to the model. So here we ask the model to describe the sentiment of the reviews strictly as positive, neutral, or negative. It's always good custom to add examples, like this is a positive review and that is a negative review. Finally, we provide a variable called review within double curly braces. The value of this variable is going to be replaced by the values from the review column from our input data table upon joining our AI model with our input data table. So now that we have our input data and we've got our AI model, let's join the two to get predictions. In MindsDB, you can join the input data table, here Amazon reviews, with the model sentiment classifier using the custom join statement, which does not require on clause, which is implemented implicitly. So here the required thing is that input data table has a column named review, because in the prompt template, one of the variables we defined as review. Then upon joining input data table with the model, the review column from our input data table is going to be fed to the model, which then processes it according to earlier defined prompt template and completes this prompt template with a value of positive, neutral, or negative. This process happens for each row in our input data table. And after executing this select query, we see that our data is enriched. We've got a third column sentiment that stores sentiment for each of the review as predicted by the model. So that was a simple example of how MindsDB works. Now let's talk about MindsDB's architecture. So as I said, MindsDB bridges the gap between data and AI. So on one hand, we've got data layer. You can connect any relational or non-relational databases, vector databases, data warehouses, data streams, or applications. Upon connecting it to MindsDB, MindsDB can access your data and use it for training the model and making predictions. Then we've got an AI layer. We provide a number of AI engines that include some of the popular AI engines, but also we provide the BYOM feature, which is a shortcut for bring your own model. So within MindsDB, you can use popular AI frameworks, or you can bring your own custom models, upload it to MindsDB, and use all the features available at MindsDB. So to summarize, you create a model using one of the available AI engines. Then you can train it using the connected data and make predictions, which you can then feed to your applications or other developer tools. More on how to feed your predictions into applications in the following slides. How to deploy MindsDB? Well, at the moment, we are upgrading our cloud environment. So it is not possible for you to create a cloud account at MindsDB. So currently, we encourage you to use our self-hosted open source version. You can deploy MindsDB locally using PyPy or Docker. The instructions on how to do that can be found in our documentation. How to connect MindsDB or how to interact with MindsDB. So as I mentioned earlier, MindsDB provides 5 development environments and 5 syntax options. So MindsDB provides a custom MindsDB SQL dialect that includes our custom comments like create model or create job. So you can use MindsDB using the SQL syntax and also connect it to SQL clients such as dbeaver and interact with all MindsDB objects from other SQL clients. Another option is the same for Mongo clients. MindsDB provides the same custom syntax for MongoQL. You can connect, at the moment, you can connect MindsDB to Mongo Compass or Mongo Shell and interact with it from Mongo Compass or Shell. Then we offer also REST API endpoints. So you can integrate MindsDB into your application using REST API endpoints and interact with all the objects. Then we also have SDKs. Currently, we offer JavaScript and Python SDKs. So you can interact with MindsDB directly from your JavaScript or Python code. All instructions how to set up MindsDB on all these 5 environments can be found in our documentation. So before I mentioned that MindsDB bridges the gap between data and AI. So obviously we offer numerous data sources and AI engines. So let's go over it briefly. At the moment, MindsDB offers over 150 data handlers, which are based on popular databases such as MySQL or Postgre, or applications including Gmail, Twitter, and Slack, which is very popular to use for the chatbots use cases. All informations on how to connect these data sources to MindsDB can be found in our documentation in the Integrations tab. Then on the other hand, we've got AI engines that are based on popular AI frameworks. We provide a number of large language models, including OpenAI, Hugging Face, LangChain, Llama Index, and more. Also, you can bring your own model to MindsDB using either Rayserve, MLflow, or our custom BYOM feature that enables you to upload your Python code with your model's implementation to MindsDB. Furthermore, we've got a number of automated machine learning models. That includes Lightwood, which is MindsDB's custom model, and also a number of time series models, including Nixla and Merlin. Also, our default Lightwood can be used for time series model, as you will see in the upcoming demo. So before moving on to the demos, let's briefly go over the available resources. MindsDB documentation is a place where you will find all instructions and troubleshooting guides on how to use MindsDB, how to connect different integrations, and more. We've got also a MindsDB community Slack, where our core MindsDB team is available to answer your questions. So you can join our community Slack to engage in conversations with our core MindsDB team, ask questions, share your feedback. And finally, our MindsDB GitHub repository. As MindsDB is an open source project, we store all our code base in GitHub. So that's the place from where you can install MindsDB locally. You can find all the instructions in our GitHub repository as well. Now it's time to move on to the demo part. First, we are going to present a demo on automation that uses custom jobs feature. So in this demo, we are going to fetch trading data from Binance, which is a popular cryptocurrency platform. And we are going to use this data to train a time series model within MindsDB. Then using these time series models, we'll make forecasts for the future and set up an alert system to notify us about the real-time trading data forecasts. So let's go ahead and start with data setup. So first thing, we are going to connect Binance to MindsDB. So Binance is one of the data sources, one of the integrations that provides data. So we use the create database statement to connect Binance to MindsDB. We give it a name and we define engine as Binance. In the case of Binance, you do not need to provide any connection parameters. Therefore, this command is sufficient to connect from MindsDB to Binance, which I have already connected, as the message says. So then once you connect it, you can find it in the left-hand side object tree as my Binance. So our input data is going to be trading data for the BTC USDT trading pair. So let's have a look at our input data. So it contains the open time value, which at the moment is in the ebook format, but later on we'll convert it to the timestamp so we can see the time, then open price, high, low, and close prices for this specific trading pair. So we are going to create a model that will predict the open price value for the upcoming timestamps. So now that we have our input data ready, we can move on to creating a model. We use again the create model statement. We call it cryptocurrency forecast model. And here is another clause which was not mentioned before, the from clause, where we provide the training data for the model. So our cryptocurrency forecast model is going to be created, then trained with the data from Binance, and then deployed within MindsDB as a virtual table. Then in the predict clause, we define that we want to predict the open price value. As it is a time series model, we are going to order the data by open time timestamps, window 100 means that when the model makes forecasts, it is going to look back at sets of 100 rows. In the case of Binance, the Binance data is updated every 1 minute. So the interval between the rows is 1 minute. So window 100 means that the model looks back at sets of 100 rows, or equivalent to 100 minutes. And as you may guess, horizon 10 means that we are making forecasts for the future 10 rows or 10 minutes. So by running these comments, you can create a model, which may take some time to train it. So I have created it earlier already. And then you can use the describe comment to see that whether the model is ready to use. So here the status is complete. So we can go ahead and use this model to make forecasts. So before we make forecasts, we'll save our input data into a view. As we focus on a specific trading pair, here it is BTC USDT, it will be easier for the eye if we create a view that stores this latest data. And this BTC USDT underscore recent view stores the recent data from Binance, which will be used as our input data table. Then we are going to join our input data table with our cryptocurrency forecast model. Here, we must also define that open time must be greater than latest, where latest is a custom MindsDB keyword. So this condition basically means that we want to make forecasts for open time values that are greater than the latest open time value stored in our training data. So we are going to make forecasts for the future, in other words. Then from the model, as you can see, we alias the model as M, and from the model, we select the open time value and the open price value, the forecast for the open price value. So here we are converting it to timestamp, and we select the open price for each open time. So let's run this comment to get some forecast. And as you can see, at the moment it is 16:28. So the GMT time zone is 15:28. So the forecasts should be made for 15:29 for the following 10 minutes. And here you can see we've made forecasts for 15:29 for the following 10 minutes. Okay, so now we've got data, we've got model and forecast. So it's time to add automation to the mix. We are going to create an alert system. We are going to send notifications to Slack with the real-time trading data forecasts. So Slack is an application, which is another data source available to connect to MindsDB. So again, we use the create database statement, we give it a name, we use engine as Slack, and here it requires a token as a parameter. You can find detailed instructions in our documentations in the integrations tab on how to connect Slack to MindsDB and how to generate the required connection parameters. So I have already connected my Slack to MindsDB, as you can see on the left-hand side here. So we can go ahead and test this connection by inserting into our BTC USDT Slack app the default channels table. We insert the channel name and text of the message. So our channel name is Binance Forecast, and the message is that we are testing Slack connection. Let's go ahead and execute this command. And you can see that our Binance Forecast app sent this message to the Slack channel. So now we can go ahead and create a job. So to do that, we use a custom create job statement. We give it a name, and then within parentheses, we place all the comments that we want the job to execute. Finally, at the end, we are scheduling the job. So you can provide a start timestamp, end timestamp. Both are optional and both come in GMT time zone. So if you are in a different time zone, you should be careful while using this start and end clauses. And we say that we want the job to execute every 5 minutes. So you can imagine that the model makes forecasts for the future 10 minutes and the job will execute every 5 minutes. So there will be an overlap between 5 of the forecasts. So you can, of course, customize it to your use case the way you like. So let's go over what the job does. So in real-world use cases, oftentimes we deal with dynamic data, which is updated every hour or even every minute, like in the case of Binance. So we want our model to be trained on the recent data. That's the reason why we use the retrain command. We are going to retrain our cryptocurrency forecast model using the recent data from Binance. Then we provide the join learn process equals true, because this parameter ensures that the retraining process, which may be time consuming, which may take a minute or two, will complete first before we start making forecasts. So that's the first step. The job is going to retrain our model to improve its accuracy and performance using the latest data from Binance. In the next step, we are going to insert into our Slack channel. First, we insert a static message that here are the forecasts for the next 10 minutes. And then we are going to insert the forecast. So here we are concatenating the timestamp. We choose the open time value from the model and its corresponding forecasts for the open price selected from the model as well. We select from our input data table, joined with the model, and again we specify that the open time must be greater than the latest open time value stored in the training data. So let's run the job to get the forecast. So the job was created. You can have a look inside the jobs table to make sure the job is running. We see that the job started as 15:33, which is a GMT time zone. And the first run of the job is started at the same time as well, because if we do not define the start clause, by default, the job starts at the current timestamp. So the first run of the job is ongoing. You can also query the jobs history table, which stores history of all executions of the job. So if your job did not execute as expected, the jobs history table is where you can find the error messages and try and troubleshoot it. So I see we've got some notification in our Slack channel. So it is 16:35, which is 15:35 in GMT time zone. So we've got our forecasts for 15:45 and for the following 10 minutes. We can try and query the jobs history table as well. So you see there was no error message and the job executed just once. So here, because we did not define the end date and timestamp for the job, to disable the job, we need to run the drop job statement. So that's how you can easily automate any AI workflows using MindsDB and its custom jobs feature. Now, my colleague will present demos on agents and chatbots that show you how to easily create chatbots using the custom syntax provided by MindsDB. Thank you.
Hello, everyone. I'm a backend developer here at MindsDB, and today I'm going to show you how to create a text-to-SQL skill, connect it to an agent, and then publish a chatbot to Slack. So what could this be useful for? Let's say you have employees inside a big company and they need to query a database. They're looking for things like the total sales of a product in the past week and things like that. But not everyone is familiar with SQL or how to query a database. So when you create this chatbot for Slack, those employees can ask it regular human questions and get the answers they need fast. So let's dive right in. Let's start by taking a look at what data we're going to be working with today. So we are going to be using OpenBB as our data source. So let's go ahead and connect that to MindsDB. And if you can see here on the side, if you expand the data source, we have access to all sorts of data provided by MindsDB. But today we're going to be focusing on historical currency prices and historical crypto prices. So let's just take a look at those and see what they look like. And as you can see, it has what you typically expect from historical prices, the date, the open, high, low, and close, and so on for that currency pair. And same thing for our cryptocurrency prices here with Ethereum and USD. Now, let's actually connect this data to a chatbot and publish it to Slack. All right, first thing we need to do is create the underlying model that our agent will use. And right now we're going to be using LangChain and OpenAI ChatGPT-4 to answer any questions. So now that that model is created, we are going to create a text-to-SQL skill that is going to use the historical crypto prices and historical currency prices that we took a look at earlier. You can simply think of a skill as a tool that an agent can use to help answer your questions. So let's go ahead and create this text-to-SQL skill. And now let's create an agent that uses the skill and model that we just created. And now finally, it's time to hook this up to Slack. First, you're going to need to follow some instructions to actually create a Slack app, set it up, and then connect your chatbot to it. But you can find all of that in our documentation. I've already done that, so I am just going to connect MindsDB to Slack right now. Then I'm going to create a chatbot that uses the agent that we just created up here. And it's going to use Slack that's connected to MindsDB. And as you can see, the chatbot was successfully created. And now we're going to start interacting with it a bit on Slack to see how it works. Okay, let's start off just by saying hello to be polite and see what's going on behind the scenes. So for this, nothing special is happening. It doesn't need to use a skill, so it's just responding normally. Now let's ask it something a little more involved, something that we'll need to query a database. So let's ask it, what was the average open price of Ethereum USD in 2023, and see how it handles it. So right away, it knows it needs to use that skill, and it's not always going to get the query right on the first time. So it uses the information it got from the error, and it sees that this should be symbol and not pair. And then it tries again, and it successfully constructs the correct query and gives us the answer that we're looking for. Next, let's ask it something similar, but for historical currency data. So let's ask it, what was the highest rate of CAD USD in 2023? And as you can see, it identifies it needs to use the query tool again, the query skill, and it is going to do the same thing where it is going to not write the exact correct query on the first try. It is going to try again, and it ran into an issue. Now it is using the wrong column. So it's getting the schema of the database to get all of the columns. And finally, it came to the correct query at the end and gave us what we're looking for. And there you have it. We've successfully created a text-to-SQL skill, connected it to an agent, and published our chatbot to Slack. This can be very useful for non-technical people inside a company who need data to get things done. This is just the beginning. Feel free to explore more features and functionalities of MindsDB, and thanks for joining me today. All right, now that we've created a text-to-SQL skill, I want to show you guys another useful skill that you can use with chatbots called knowledge base. So for a knowledge base, you could have one or more data sources, whether that's a database, a file, or even a website that you crawled. You could insert those data sources into the knowledge base, and then behind the scenes, it's going to use an embedding model to convert that data into vector embeddings, and it's going to store it in a vector database so that the knowledge base can do a similarity search on it later. And if you hook this up to a chatbot, whenever you ask the chatbot a question that requires the data in the knowledge base, it will know to do a similarity search to get you the answer that you need. So as always, let's take a look at what data we're working with. We will be making use of OpenBB's world news data. So here we have a bunch of different news items, and we have the date, title, and text for all these different news items. Next, as I was saying before, we need to create an actual embedding model and vector database for our knowledge base to use. So let's go ahead and do that now. Let's create the embedding model. And let's configure ChromaDB to be used with MindsDB. And now we're going to create our world news index in ChromaDB. And as you can see, we're just inserting some dummy data to get started here. Now it's time to actually create our knowledge base using the embedding model we just created and the ChromaDB collection that we just initialized. Now let's actually insert some data into our knowledge base and see what we're working with here. And there we go, it inserted all of our content. Now let's actually do a similarity search to try to find an article related to artificial intelligence. And there we have one right here. And let's try to find one related to China. And there we go. Now, what you've all been waiting for, let's connect this knowledge base to a chatbot. Like our text-to-SQL skill, we have to create a knowledge base skill that is going to use the knowledge base that we just created, and we can simply update our agent that the chatbot is using to use this new skill. Now, when we interact with our Slack chatbot, it should be able to use the data in the knowledge base to answer our questions. Let's take a look. Now let's ask our chatbot something that it needs to use the knowledge base we just created to answer. Let's ask it what's happening with artificial intelligence in the world, since there's at least one article in the knowledge base about that. And as you can see, it knows it needs to look it up in the knowledge base. And since there is at least one article that has to do with AI in the knowledge base, it puts together a relevant response for us. Now let's try asking it what China is involved in terms of world news, since there's also at least one article about China. And as you can see, same thing, it knows it needs to use the knowledge base to answer this, and it comes up with a relevant answer. And there you have it. We just went through how to create a knowledge base, how to insert some data into that knowledge base, and how to connect all of that to a chatbot. Thanks for joining me.
Well, guys, that wraps up our MindsDB Hackathon workshop. A huge thank you, Martina and the MindsDB team, for joining me and sharing your insights and invaluable expertise. I'm really excited to share this with our community. And remember, This is just the starting point. MindsDB Hackathon is in full swing, and we are very excited to see all the AI agents you bring to life. And keep the code flowing, engage in discussions, share your progress in our communities, and ask for support if you need any assistance or any help. So if you haven't registered yet, there's no better time than now. And this is actually your chance not only win amazing prizes, but also to make a big contribution to the world of AI. Happy coding, and thanks again, Martina.
Thank you, Danny, for having us, and good luck to all hackathon participants. Thank you.